everybody. Welcome to another episode of DE Editors Chat. We're glad to have you with us here again. I'm Senior Editor for DE. My name is Kenneth Wong, and I also have my colleague, Brian. Brian, self-introduction, please.
Sure, this is Brian Albright, Editorial Director at Digital Engineering. Glad to be back, Kenneth.
Sure, and glad to have you back from Autodesk University. Is there anything worthwhile that you saw that you'd like to share with us?
Definitely, there was a lot of news that came out of AU25 this year. The big thing, though, for our engineering readers was the advancements in what Autodesk is trying to do with artificial intelligence. They already had an Autodesk assistant in Fusion, and they've added some more features to that so that they can automate a lot of the more tedious tasks in Autodesk Fusion. But the big news, as far as I was concerned, was the introduction of generative AI in the Fusion product. And what that meant, and the example that CEO Andrew Anagnost gave while he was giving his keynote, was you can basically use natural language prompts to go from a blank page to a basic CAD design. And what he did was he, put a prompt in to create an air fryer, and it gave him a very basic air fryer design. And then from there, you can go in and customize that. Um, that feature definitely, it keeps humans in the loop, and they kept emphasizing that this is not to replace the designer. It's just to get them started faster and get some of the basics done and take some of the tedium out of it. But I asked him during the briefing because the model that it's trained on is using not just a specific customer's training set of CAD designs, but also a larger group of designs are used to train the model, from other customers. And this data is sort of anonymized, but I asked him, if you go in and say, give me an air fryer, and what it gives you is a Procter and Gamble air fryer, but you don't work for Procter and Gamble, that could be a big problem, right? Because there's a lot of IP involved in this. So how he explained it to me was that if the generative AI engine gives you a design that looks like anything in the training set, it automatically tosses it. Um, I'm still not exactly sure the details of exactly how that works, but that's how they're sort of, keeping other people's IP from crossing into these designs that are generated in Fusion. Um, Also talked to them about, AI engines tend to hallucinate sometimes, and uh, Autodesk's response was that they provide a lot of context and data around the training model that minimizes or eliminates the possibility of hallucination because you're giving it more detailed instructions about what the model is supposed to give you. Uh, See how that works in practice, but it was really interesting, and I'm going to be curious to see how Autodesk customers respond to having that capability now.
There is definitely a lot of talk about support for natural language and the use of natural language prompt to start off the creation of your 3D model of your design or your part, as the case may be. The point that you're raising is something that we will continue to wrestle with, I think, going forward, because obviously many of the simulation software and design software makers are going to include the ability to train an AI engine on specific sets of data. In the case of you training using your own proprietary data, there's no conflict about it.
Hmm.
But there is a trust factor that is involved, right? Where you put your trust in the software makers that they are not going to use your data, meaning you are the customer, your your data or the customer's data for training purposes. If that's the case, it raises all kinds of IP questions and
Mhm.
uh, competition questions that are still yet unresolved. Unresolved to me anyway, at any rate. Yeah.
Yeah. And there's just sort of a foundational issue. Is this what engineers want AI to do for them? And I don't know if anybody has the answer to that yet because we're still in the very earliest stages of this.
That's right. I think I'm thinking that to some extent it's a welcome change because it gets rid of the mundane drawing and drafting thing that usually is the beginning stage of a design creation, right? Usually you start with a 2D sketch and then
Hmm.
extrude it into a 3D model. Uh, but to what extent would typical engineers want to get rid of that? And to what extent would they want the AI to take over the really creative process that many of them would actually enjoy and would
Right.
like to be in control of? That still remains a question that is open to me, it seems. Yeah.
What we're talking about now is sort of on the CAD side. We're also seeing a lot of AI implementation on the simulation and analysis side. And I know you heard something about this when you were at the Ansys show.
Yes, Ansys simulation world is a much smaller show compared to Autodesk University. Of course, it usually happens in Silicon Valley, and I happen to live closer to Silicon Valley in San Francisco. So I took the train and I went there to attend, and you were kind enough to reimburse my train ticket for me so I could go there.
Anytime, Kenneth.
Yes. Of course, as we know, Ansys has recently been acquired by Synopsys. So Ansys CTO is now in charge of the simulation the simulation division. Now, let me make sure that I get his new title right. It's not as simple as CTO anymore. His name is Prith Bernaji, and the gentleman is now Senior VP of Simulation and Analysis Incubation Group at Synopsys. Essentially, he told me that he's doing exactly the same thing he has been doing. But Kenneth also mentioned that he expects the role of co-pilots to grow. Co-pilot, as you talked about, where we think of as previously in Windows is the annoying little paper clip, but this is
Right.
the more hopefully the more intelligent version of that is some AI engine that could give you prompts and warn you that you might be doing something that you shouldn't be doing in your 3D model and things like that. Or if you have questions that normally you would go look for answer in the community chat board, these kind of co-pilots may be able to just answer because they have access to all these information and they can respond to natural language. Now, here are some audio clips from my interview with Prith.
This is where we started with Ansys GPT, which is like a co-pilot. But then you can say, well, why do you just answer it in English? Why don't you actually do the actual setting of the solver? So it turns out with HFSS, our solver, with Python, you can say an option of tau meshing and you can do it. So that's where it is headed. It's essentially going in and doing the job of setting it for you. That's the co-pilot. But then these are based on sort of hundreds of designs that you have done. Now, if you are a designer and you like a particular form of design, in the future, you will be personalized to the designer. So this is a journey that we are on, and is that journey from the engineering co-pilot, the assistive co-pilots, to the generative co-pilots, to what is called agentic AI, which our CEO Sachin talked about re-engineering engineering, how products will be designed in the future with these agentic agents.
All right, that's our on the road section, as it were, the shows that we recently attended. Now, let's also talk about the two biggest acquisitions that recently happened that I believe kind of alter the simulation and design landscape. First, we have Siemens acquiring Altair, and then we have Synopsys acquiring Ansys. So, what are your thoughts on that, Brian?
Well, I mean, we're seeing a lot of the silos fall away where a lot of these solvers operated, and in design as well, where electrical was separate from mechanical, which was separate from software. And we're seeing a lot more convergence of that, both among the end users who are creating these more complex products, and also with the software vendors who are trying to expand, their suites to address as much of this space as possible. In the case of Siemens and Altair, Altair has a lot of complementary um, simulation solutions. Siemens, of course, is a very big company. They have not only like manufacturing automation piece, but they've also got PLM as well as a variety of different simulation tools that they've acquired, through other acquisitions. Synopsys and Ansys, I think, really illustrates that idea of, the convergence of electrical and mechanical, and that really brings those two together. And we've seen that across the industry too. The other acquisition that happened a few months ago too was Cadence picked up Hexagon's design and engineering business, which is a big chunk of their software business. So we're really seeing all these companies just trying to broaden their portfolios.
Right, because we used to have companies that sell ECAD, electronic CAD, which essentially caters to the chip makers and the CPU makers and that sort of that part or electronic components. And
Mhm.
then we have the mechanical design software. But those two quickly come together. And ultimately, in the case of Synopsys acquisition of Ansys, that's essentially two of the biggest names in these sectors coming together. The thing that is interesting, though, is Ansys, when it was growing big in the simulation, the FEACFD kind of simulation world, it also went out and acquired some smaller EDA makers. But of
Right.
course, eventually, Synopsys ended up swallowing Ansys, so they came together. And in the case of Siemens is talking about incorporating Altair's products into its accelerator portfolio, the Siemens portfolio that includes some simulation software and things like that. So we're definitely seeing the emergence of giant companies that offer electronic design and simulation and design. So you can go from chip design to mechanical components to simulating the whole assembly and things like that. Everyone's ambition seems to be trying to become this kind of the be all and the end all of engineering software companies. Is that what is that what we're looking at?
I think so. I think that they're trying to, capture as much of their customers' business as possible. Because our engineering readers tend to have very heterogeneous software environments because they need to simulate so many different things. But often those tools are isolated from each other because they're from different vendors. Some are very small, some very, boutique vendors. Some of them are open source tools. So it'll be interesting to see how customers react to some of these acquisitions and how they manage their software deployments.
Right. The expectation is that when these kind of acquisitions happen, at least the data transfer, people hope, is going to improve. So
Right.
if previously you had trouble communicating, your ECAD program have trouble communicating with their MCAD program, when two companies that owns these programs come together and become one, you hope at least that data export exchange would become easier. But and that's the expectation. And quite often that does happen because you have two development teams now working closely together, and there's no longer the threat of competition. So they have shared interests to make sure that this data exchange is smooth. But it doesn't always result in a smoother transfer after post.
That is true. And
Yeah,
and especially on the simulation side, there's always this demand for some sort of interoperability.
right.
And the vendors can't address it separately. I don't know if they can address it better together, because you still have two different tools developed, on two different solvers. So I
It's
guess we'll
true.
see.
That there is a limit to it too, that we have to acknowledge as well, right? Because people who are designing electronic components and people who are designing mechanical components, the sheer type of geometry that they create are different, and the simulation regimen that they deal with are different. For example, structural simulation, very dominant in thinking about what are going to fall apart in your product, but in electronic design, they are more concerned with thermal simulation and the flow of things that are going through tight canals and things like that. So they're not always the same. So that we also have to acknowledge that there is a limitation as to how how tightly these programs could actually integrate. But at least we
That's
hope
true.
that the data exchange will be easier with these things.
Mhm. I know we've been discussing a lot of AI related topics earlier in our conversation, and you recently reported on a report from John Petty Research that gives us some more insight into the AI market.
It is actually a report about, let me give you the report title. The report is AI Processor Market Development. And it's a report on AI processors. So by extension, we can say a lot, or we can conclude a lot about the AI market. Essentially, the AI processor market is growing according to this JPR report. JPR, of course, stands for John Paddy Research. It's a very well-known analyst firm and consulting firm in our space. So the report identifies 121 companies that are now making or planning to make AI processors that would range from tiny IoT class kind of devices to things that will go into processes that will go into data centers that will do supercomputers. These have attracted about 13.5 billion in startup funding since 2006, and many of them are raising probably 100 million or more in the past years alone. That's what JPI report is saying. The interesting thing about those is that even though the report acknowledges that US is now the leader, it's warning us that we should not discount some of the smaller startups that are coming up from other parts of the world. China in particular could actually challenge the dominance of US. That's what the report is generally saying.
Right. And it also just points to the scope of the demand, for the processing power that's going to be needed for all of these AI-enabled applications. So it'll be interesting to see how that develops as we go forward.
Correct. That's true. When we talk about China, of course, we know that DeepSeek is one of those names that keep coming up because it actually essentially came out of nowhere before
Mhm.
anyone had taken notice of it and came up with a way to do AI without relying on powerful GPUs that um, the major players like NVIDIA and AMD make. So it's definitely something that something that something that shows that there are different smaller companies and innovative companies that could challenge the current dominance of the bigger players. Let's talk about
Uh,
our summit because AI
yeah,
is also part of our summit's
yeah. Speaking
keynote.
of AI, we would be remiss if we didn't mention October 30th at noon Eastern, our Digital Engineering Design and Simulation Summit. And the keynote is focused on exactly that topic, AI, Kenneth.
Yes, the keynote, which I will be moderating, we will also be talking about the role of co-pilots because essentially we want to raise a question. If AI is our co-pilots, can we trust the advice that these co-pilots are giving us? Are they reliable enough for design and simulation? So we have speakers. One is Jean-Paul Jean-Paul Stein from McKinsey and Company, and another one is Sandy Park, another analyst from SimData, also another prominent firm that publishes PLM report and a firm that we turn to whenever we need comments.
And if you're interested in attending, just visit digitalengineering247.com /summit 25.
That's right. We also have other tracks too. So this is the keynote, but we have a simulation-led design track. We also have additive manufacturing track, and we also have the hardware track that this year we happen to be talking about harnessing cloud-hosted high performance computing for simulating large scale simulation jobs. And we also will be talking about digital twins. So that's another track. So whatever segment that you are interested in, I believe we have a track that is relevant to you. So sign up and I hope to see you there online.
Very good. Well, I think we're out of time, Kenneth.
All right, that's it. Thank you very much for joining me, Brian. I'm going to let you go back to your busy day and I will do the same. Okay. Audience, thanks for joining us. Until next time, I'm Kenneth Wong, Senior Editor for DE, and we are out.